Well guys, I'm ready for my head job. But believe me, I really don't want to do this one alone. It'd be nice if I had some help. You know, at least somebody to just lend a hand. I asked my girlfriend if she was up to the task, but as luck would have it, it's Shark Week, if you know what I'm saying, so she's not in the mood. So I guess maybe I'll just have to pull this one off myself, as usual. So, I'm sure a lot of you are noticing something that I've done here. Come on, some of you know what I'm talking about. I can tell. I see it all over your faces. And that, of course, would be the fact that in this whole entire video thus far, we have not spent one single dime on any special anything, granted with the exception of that telescopic bore gauge, which actually you don't really even need, as we saw. But the idea is that had we brought this to a machine shop, they would have told us pretty much the same thing, and we would have spent a minimum $160 just to find out that the repairs and the machine work and the parts we need would have sent us way over budget, and we would have just lost that $160. So the idea is that we've saved all of that money that we can put now towards a better used engine and some other work on the truck. So granted, the telescopic bore gauge may be an exception, and also the possibility that maybe some home mechanics may not have a feeler gauge set, which is really the only specialized tool we've needed. But you can get a feeler gauge set for like $6. And you really don't need the telescopic bore gauge, especially if you find you're within spec. You definitely don't need it. But even if you're out of spec, as you see, using some tactile sense and observation, you can get by. But anyway, enough goofing around. Sorry for the goofing around in the last video too, but it's time to get to work because now we've got some decisions to make. The work that we are going to do from here on with the cylinder heads and then also in later videos with the reassembly is going to require some specialized tools that are used only for the purpose of engine rebuilding and nothing else. So you need to make decisions if you're going to buy them, maybe you can rent them, and which ones to get for your particular application. And also that is to be considered with your cost, as well as the fact that there is going to be a hella amount of work involved too. So let's go see what this entails. Behold the cylinder head. And I do have another video that talks in fairly good detail about installing and removing a cylinder head from a vehicle, replacing a cylinder head gasket. But what it does not cover is the disassembly of a cylinder head and the inspection. But right now, what we're going to have to do on this for our inspection, we of course want to do, as mentioned in the other video, we will want to clean this surface off very, very, very thoroughly with a wire brush. I sometimes use a block of wood and some sandpaper, and we'll want to, of course, check our clearances to make sure that we don't have any warpage. There will be a specification for this, and by putting a flat hedge and a feeler gauge at the specification, all of this is covered in the other video. But what is not covered is the disassembly. And for that, we've got to remove our valves, which means removing our valve springs, which means removing the valve keepers here. You can kind of see this maybe two-part. Over here you can see it a little better. There's a little space here, so there's a little two-part keeper system that basically keeps the compressed spring on the valves. And then, of course, on the bottom of the cylinder head, as we saw, you have your valves here. The smaller ones will be your exhaust valve. The larger ones will be your intake valves. You can also tell because by looking through the intake port here, we can see the stem of the valve partially. So to get rid of these valve spring keepers, we will need some special tools. So your first option is your overhead screw type valve spring compressor tool, which basically it works not too much unlike a strut spring compressor for your suspension. You simply hook the tool into the spring, center it over your keepers, and then by turning the handle, which takes a little bit of time and effort, to be honest. It will, of course, compress the spring, and we'll do this with another tool that is easier to show on camera. And by compressing the spring, we will be able to access these keepers that are holding the spring in place, remove them, and we can remove the spring and valve and do some measurements. One advantage with this particular tool is that it will be possible to remove the valve springs when the cylinder head is in the car on the engine. If you simply hold the valve in place with compressed air by putting compressed air through the spark plug hole and making sure that the valve is held with compressed air, you can replace like the valve seals, which we will inspect and of course always replace when we do this work. So there is an advantage to that. It's also much handier if you are removing valve springs on something like my Trans Am, where a lot of the engine is located way back under the cowl. So depending on your application, if you're especially removing the valves while the cylinder head is in the car, then this is a good option to use. But it is extremely time consuming. The other option is this big C-clamp type tool that looks like some type of torturous dental instrument maybe. And the idea, as usual with removing the valves, the trick is you have to keep the valve stationary while you compress the spring, and that is what this tool is designed to do. Obviously, this tool can only be used when the cylinder head is removed from the engine. And the idea with this is you simply adjust this stem here to hold the valve in place. In this case, I'm on the exhaust valve. And then this top part here is going to catch onto the top of the spring. And you basically use your hand here to compress the tool. And by compressing it, it holds the valve in place while the spring is compressed, such as this. So once you get this adjusted properly, if you squeeze real hard on the handle, and it has a ratcheting mechanism here to maintain your place. All right, and there definitely is some adjustment that's necessary here, but well, if we, I'm going to put some safety glasses on and just cap back this retainer a little bit, but we should be able to see. You can see the valve keepers there. There we go. And those you can just remove with a magnet like that. And you can see there's a little groove in the valve stem. So by removing both of these keepers like that, you'll be able to then release the tension on the tool very slowly. You don't want anything flying out at you. And remove the valve spring and, of course, then the valve. But there are some disadvantages to this thing. So disadvantage with this thing, the cost. I actually don't remember how much these cost. I want to say off the top of my head, because it's been a good 7 years since I've bought these, this overhead one that can work in the car also, maybe around $30, and this one at least twice that, I'm sure. Another thing, there's a lot of adjustments that you have to make with this, and sometimes you have to readjust every single use. It can be actually really time consuming. Another major consideration with this one is you have to have a very strong grip to squeeze that spring with this tool. There are versions of it that are pneumatic or hydraulic, but if you're going to do a manual version of this, this is going to be very painful if you're doing, say, 16 or 32 valves. You'll be quite sore by the end of that day for sure. It is very hard to squeeze. It is probably not the best if you're a weak, girly man or unusually effeminate or something, you know, like the people that give me thumbs down on my videos. So we have that as well. There's another option too that I recently discovered that actually puts both of these tools to bed. Let's go check this new toy out. So what we have here is a little gizmo from Lyle. Again, it is not a cheap investment, but again, decisions to be made, and because I do some head work like this from time to time, this became a rather good investment. This is a valve keeper remover and installer set, and it is so simple, it will just make you cry. So the design of this thing is so simple, it will just make you sick that you didn't think of it yourself. Basically, it's just a magnetic tube here that will fit over the valve on the spring, and by pushing down sharply, or better yet, using a hammer, you simply compress the spring, and because the magnet will catch the valves, when you go ahead and slowly remove the tool, you will have the keepers nice into your little magnetic holder there, and of course the spring and valve can be removed. So obviously it goes without saying that if I push down on this spring with this, it's no different than a rocker arm. The valve underneath it here is going to open and close with it. So the trick is to, as with all these remover tools, you need a way to keep the valve stationary, and by putting a shop towel under there, that's going to prevent the valve from opening. So I'm going to go ahead and try this with the hammer, because since my cart is a roller cart, I'm definitely not going to be able to push down on it. And we'll show you how this works. Now, it should be pointed out, before we get all excited and start removing our valves with our new toy, since we are actually going to remove a valve this time, there is actually a specification for the compressed height of the spring. Now, because of the design of the cylinder head, it's very, very difficult to measure that. So there's actually a special micrometer tool. Again, this is where we're getting into some special tools. I actually do not own one, but I just wanted to point that out. Again, keep in mind, I am not condoning what I am doing in this video. This is mostly for demonstration, and also to help if you kind of sort of have no choice, or maybe just want to try this or something. But the proper way is to measure the compressed height. I will measure the spring height when it's relaxed. Another measurement that we would normally do on a spring is the tension. You need, again, a rather significant special equipment for that, which of course I don't have. The proper way to do this is to bring this head to a machine shop, and for maybe $150 to $200 per head, they will do all of this work for you, and measure everything up, do your valves and all that. Obviously, we do not nearly have that within our budget, so we're going to do as much of the work ourselves that we can and determine only things that need to be done. So I just wanted to remind you of that. But let's go ahead and get this valve out. All right, that's pretty easy. As you can see, the magnet's doing its job. We've got the retainers in the magnet. There's the first keeper, and the second guy right there. And you can see that that's much quicker than either of the other methods. For our spring, we simply remove the spring, and then we can do our inspection of the valve and the spring. Also, we can see here our valve stem seal. This one is called an umbrella seal. This is what prevents the oil from running right down into your valve. As many of you know, if you have the symptom of a engine startup, that a lot of blue smoke and burning oil comes out of the engine at startup after it's resting overnight, but then it quickly burns away. Many times these seals are the problem, and we are of course going to replace these seals in any rebuild. So let's go ahead and do our spring inspection as well as our valve inspection right now. So one of the things we'll want to do, the only measurement that I really actually can do on this spring is the relaxed height. Now remember, when we take the retainer off here, we want to make sure that we maintain the orientation of that valve spring. So I'm going to go ahead and remove that, and we're going to measure the relaxed height of this. The specification on this model is supposed to be somewhere around 2.26. And we are at about 2.2595. So we're in good specification with that. Don't forget, we've got lots and lots of other of these springs to measure, so don't underestimate the amount of work and time that this is going to take. So before I remove this valve, one of the things I want to do is I want to feel around the valve and make sure that there's no major burrs or anything that's going to scratch my valve guide when I pull the valve through. And I can feel there's a little bit of a lip here, which is pretty common right on the very end of the stem. So what I'm going to do is just lightly sand or file that down so that I don't damage my valve guide when I pull the valve through. And the other thing before I pull this valve through, I want to kind of move it up and down and spin it a little bit and make sure that I don't feel any obvious out of round, and I do not. So when I pull this through, and actually let me do it the other way so that you can see the valve from a more exciting angle. So what I want to show here is when I push the valve and pull it through the guide, similar to your piston to bore clearance that we measured earlier, there is going to be a diameter reading on this valve, and you'll have to check that with your micrometer to specification. And technically there will also be a bore reading for your guide. Now that's going to be pretty hard to measure, so you're probably only going to be able to get away with measuring the valve stem diameter. Now one little trick that I'll do is I'll insert the valve back into place, and what I'm going to do is use my finger to push the valve, but I'm going to keep my finger over the end of the valve guide on the spring side of the head. I'm going to keep my finger over that, and then I'm just going to quickly remove the valve, and you hear that little pop like that kind of suction pop. Let's do that again. So that suction pop is sort of a little rough estimator that I use to see whether we're out of spec or not. If you do not hear that sound, then you are almost certainly out of spec with either the stem diameter on your valve or I should say, the valve guide bore diameter. If you do not hear that pop. If you do hear that pop, it does not necessitate you are in spec, but it is definitely more comforting. If you cannot make that pop sound, then there is just way too much play with the valve in that guide. So now what we can do is, of course, inspect our valve. We want to look for any cracks on the valve. Remember, if you remember back at the beginning of this series, I am not worried about the cylinder head on this car or valve leakage or things like that, because my leak down test showed absolutely no leak through the cylinder head in any way. So despite that, we still want to do some inspections, and also in your application that may not be the case. You may be doing this job because specifically your leak down test or compression test indicated an issue with the cylinder head. So we'll talk about some things to inspect and check those out. So if you are finding leakage past the valve, then one of several things may be happening. The valve itself may not be sitting square in the valve seating area. That's a pretty common one. The valve itself may be damaged or bent. Obviously that little spin test inside the bore, if you feel or see any kind of wobble or anything, then obviously you fail your spin test. Up to a certain point where all this carbon has built up that I usually like to clean off with carburetor cleaner. You can do that glass plate test like we did with your push rods to see that this stem area here is perfectly straight. Another real common thing that I'll see when you clean this area up, if your valves are okay, you often will see a crack somewhere along the seating area, and that of course would be an area for loss of compression. Actually see that quite a bit on cylinder heads where there is leakage past the valves. I believe I've seen the cracks actually more than I have bent valves or something like that. So those are all things to check. One of the things that we do want to do though, even though we think everything's okay, I like to do a little quick test to see that the valve seating area is perfectly flush with our valve. In other words, that all contact points on our valve here, which I know this valve is really dirty, I'm going to clean it up, but all of our machined contact points are sealing perfectly with our seating area in the cylinder head, and I'll show you a cool trick to do that. So what I've done is I've cleaned up my valve seating area, and I'm just spinning it around in there to make sure that it's seating nice and flush. By the way, this alone, if there's any big carbon buildup on the rear side of the valve or something like that, that alone may actually help to seal it better if you have some leakage. But what you'll notice is I now have cleaned and shined up this machined valve seating surface here. And what I'm going to do to validate my valve seating is proper is I'm going to take a real inky pen. I've got a Sharpie here, and I'm just going to use my Sharpie to fill in all around that machined surface there. You can also do this on the machined surface on the valve. It makes no difference as long as it's shiny so that you can easily see your ink. And I'm going to go ahead and draw this all the way around. And now hopefully the blue ring is in the camera there. What I'm going to do now is go ahead and insert my valve, and I'm just going to turn it a quarter of a turn with a light pressure, not real heavy, but just a light pressure, maybe an eighth to a quarter of a turn. And this is just to see that all points of the valve are seating into the cylinder head properly. You don't want to spin this all the way around, because if it is not seating properly, you're going to have the part that is seating properly make a complete circle and, of course, remove the ink, which is the whole idea of what we're trying to do here. So now I'm going to go ahead and push the valve out. I can test our valve seal again. And let's get a flashlight and see how it looks here. I don't know how well this will show up on the camera, but we can see in this region here, we have completely removed the marker material, and also on the other side as well, which doesn't show up on camera, but it's completely removed the marker material. But if we look in this region here, you can hopefully see on the camera that we do have actually almost no contact in a small region here with the presence of our marker ink. So this shows that this valve is not exactly seating perfectly into this cylinder head. So this indicates that we would probably need to get a valve job to help with that. Another thing we could possibly do is try cleaning our back of our valve a little better, but I've done about as good as I can. So it's definitely not perfect. And now you've got to make some decisions. Do you want to spend the money to get a valve job done now? Or is this going to pass the test because we did fairly well on the leak down? Don't forget that, the leak down is a little bit compromised by the fact that the rings were kind of weak. So if the rings, if we re-ring an engine, that compression is going to go to the weakest point. Will this now be an issue? So as you see, it's never easy and straightforward unless you just take this to the machine shop, which is the right procedure. Well, the slickness of this tool almost compensates for the fact that everything we seem to do on this engine finds something wrong with it, doesn't it? But there's really no question in my mind that there is some level of concern with the valve sealing, at least on that valve. And if it's that way on one, it's probably that way on the others. But of course, ideally, you would do this with all your valves. The other thing is, if you do decide to do the machine shop work, you will be able to save a pretty significant amount of money if you do all the disassembly yourself and provide it to the machine shop, because they often charge an hourly rate. So that's something to keep in mind. If you do need machine shop work, they do give you credit, I guess, towards your labor. Still want to take on this project? Then you are sick in the head. But actually, in all seriousness, it can be kind of fun. A lot of people do this as a hobby. I find it a little bit enjoyable, but now that I do a lot of other car stuff, I don't like having my garage tied up. Obviously, this engine is not nearly going according to plan now that I'm a little concerned about the sealing with the head. So now I'm starting to worry about how long this truck's going to sit in my garage. But if you're still planning on doing this, you still, as you see, if you're measuring everything up and it all comes to spec, you can dramatically get by with a reduced cost. Now, in the last video, I had mentioned that I have done this a couple times for under $500, and that's true, but it also assumes the fact that I already have the tools necessary, all the measuring equipment, dial indicators, the valve spring removers, and all that, the honing bore, which we'll see later if I continue this on. You have to keep in mind that the tools are going to really start to add up at this point, because they're going to be very specialized for only singular purposes. And if you only do this once, like to repair your daily driver, you're going to have a significant tool expense for just a single one-time use. That needs to be a consideration. So, but if you're still cool with all that and you want to do it yourself, as you see, really there's nothing magical about it. It's really a matter of just keeping good track of things, paying attention to detail, and obviously some know-how, which hopefully we're showing you here. So I think that'll do it for this video, because I gotta kind of get ready for my trip again. But maybe next weekend we'll go ahead and start looking at, if we were to go ahead and reassemble the engine, what would be involved with that. Obviously on this engine I'm not going to buy any parts or gaskets or things for it. But what we will do is maybe put the old parts back and show you the measurements as if they were new parts, so that you'll know what to look for, how to see that things are in spec, and also what other tools you're going to need to do this. So that's what we'll do for the next time. Thanks for watching. Hope you found this helpful.